All right, all right. We're going to go ahead and write a point ratio form equation of this exponential curve. And we're going to do this multiple times. So I went ahead and added some data to this screen. And we're going to use those data points to find the ratio and to build our point ratio form equations. So now over here on the right, you're going to see these data points, 223.438 and so forth, on the exponential curve. Now remember, whenever we find a rate in this, we're going to take our second term in order and divide it by the first term in front of it. So the second term and then the first term in front of it. So I'm going to take 57 and divide it 57.22, and I'm going to divide it by 23.438. When we do that, that is going to give us our ratio between those 2 points. And we can continue to do that, 139.698 divided by 57.22, and that will also give us our rate for that gap right there. And then that will remain the same, that same pattern will remain for the third gap that's there. Over here on the left side of the screen, though, you should notice that I've already went ahead and typed it in. So I've typed it in every one of these things, and you'll notice that the ratio comes out to be 2.44 for each one of those calculations. So let's go ahead and write that down. R equals to 2.44, R equals to 2.44, and R equals to 2.44. Now, one thing that we have to really pay attention to when we do exponential curves is, hey, what about the gap in data? We want a gap of 1, meaning that the ratio applies to the first data point, then the second data point, and from the second to the third, and the third to the fourth. But what we have in this case is we have from the second data point, to the 6th data point, and then the 6th to the 10th, and then the 10th to the 14th. So we have big gaps. Well, that means that in order to get from 2 to the 6, we have to go 1, 2, 3, 4 spots in which we are multiplying by the real rate, the unit rate in this case, okay? R times R times R times R. So what happens is R to the 4th, meaning going from the first to the second to the third to the 4th data point, R to the 4th is equal to this big gap of 4, which is 2.44. So we want to find R to the 1st power. Nice and easy. I just say, well, it's 4, I want 1, so I use 1/4 in the exponent. So that's what I'm going to do. I'm going to come over here and I'm going to say, okay, well, let's do 2.44 to the 1/4. What does it come out to be? 1.249. Let's go ahead and round it to 1.25. So we're going to say R to the 1st is 1.25. And there is our rate. Now, at this point, we have actually made all the most complicated of calculations in this entire problem. So let's go ahead and spread this screen out just a little bit so we can see it a little bit better. And let's bring out our graphing material so we can type this in and start making some equations. All right, so with that being said, let's go ahead and make an equation real quick. Should be pretty easy. When we look at this first point right here, which we know is going to be 2 and 23.48, we can use the point ratio form, which means we start at 23.438. So I'm going to write that down. I'm going to say, okay, well, let's write y equals 23.438. I'm going to put in my rate of 1.25, but we shifted our initial value, to the right, which is a translation. So in order to write my equation, I just write x minus 2. So let's go ahead and see if that works. Let's type that in, and then we'll work from there. Y equals 23.438 times 1.25 caret to the x minus, whoops, I don't like that. Let me put that in parentheses, x minus 2, and check it out. The exact same equation glows up. Now, can we do this from any other point? Let's pick another point on there. I'm going to write it from the last point. So let's write this from the last point. I'm going to use a pink, okay? And when we write it from the last point, I just use that same point. So I say y equals the initial value, which we're going to shift 14 now. I'm going to place it right here, 341.061. And then I'm going to write 1.25 because that is still our rate, but we are shifting it 14 to the right. So I'm going to write x minus 14. Let's check that out. Okay, so I'm going to write y equals, and let's type that in, 341.061 times 1.25. Here it, and I'm putting in parentheses this time, and I'm going to put x, moved it to the right, minus 14. Check it out, that glows. So the question is how many ways can we write this equation for this exponential equation? Millions, infinite ways, because there's so many points that we can write the equation from, just as long as we make sure we shift it in the right direction and we use that ratio that represents the individual unit from term to term to term.